Hello, my name is Abnet. In this project, we will see the configuration of storage accounts with blob service and the security measure. For the sake of lucid presentation of the project and to give you profound understanding about the project, I have decided to create 3 storage accounts. Those storage accounts with its configuration level and security level. So this is a documentation of the project, including with its architectural representation and key learnings and takeaways. So the contributor is here, it's me. So we can start from storage one. So storage one, the first configuration in the storage one is allowing public access. That means allowing the public endpoint of the storage account to be accessible through the internet. We didn't want to restrict anonymous access. So we can see how how it configured from this storage account. So in the container level, we can check the access level. Here it is container, but we can limit or restrict anonymous access if we need authentication to access this storage account. So we can use private or no anonymous access. But for this storage account, we want to access it publicly without any authentication. This is the bash script file I used to create storage account and the corresponding resources like containers. So you can find this script file in my GitHub account. I will put the link in my description. So now we can access it publicly using maybe SaaS or the endpoint of the storage account. The second configuration is its access control. I used SaaS or shared access signature to access the storage account with limited performance. That means anybody can access the storage account with the right SaaS token, but for limited time. We can limit their access level by time. Again, we can also limit using public IP address in which the storage account receives the SaaS token, or we can also use protocols in which the storage account receive the SaaS token. But public IP address and the protocol is optional, but we have to put expiration and start time of the SaaS. So under networking, here is a shared access signature. So this is the parameters we must configure because the SaaS URI is combined. It's a combination of the endpoint of the storage account and the SaaS token. This SaaS token is built from parameters. These are parameters here. Allow service. So we allow the service based on our desire. In our case, the service is blob, so we can uncheck this all. We can uncheck this all, and we can select services here. So let's access one blob in this storage account. So we created one container and we uploaded one image in this container, and let's generate SaaS. That means shared access signature, and let's see whether we can check. Let's see whether we are able to access this storage or not. So this is a configuration. We can select the key because storage account has 2 access keys, and we can select the permission here, read, and we can also add write permission. This is the start time and this is the expired time. If once the time is expired, anybody can't access the storage account even if they have the SaaS token. So this is optional. Let's generate SaaS and copy the URI. Yeah, that's the uniform resource identifier. We can use private windows to access the storage account. Here we are able to access this storage account. So this SaaS token is able to access the storage account only if within the specified period of time, So the third configuration is the security measure. In this storage account, we don't want to store sensitive data. So we don't want to create customer managed keys. Instead, we use the platform managed key. That's the default one to encrypt data. That it uses the algorithm called Advanced Encryption Standard (AES) with 256 bits. The fourth configuration is data redundancy. We use local redundant storage, but we can also change the redundancy option here. If you don't want to replicate data in other regions, we can use GRS, that means geo-redundant storage. But for this storage account, we use LRS. The fifth configuration is cost optimization. I optimize the cost of the storage account by managing the lifecycle of blobs. That means lifecycle management enables us to configure policies and rules to act upon blobs. Here we can configure policies. So here I have one rule now. So the rule is to delete blobs once they reach 10 days. They reach 10 days. So here is the if-then configuration of lifecycle management. If base blob created more than 10 days, delete the blob, then delete the blob. So in this area, or in this option, we can not only delete, but we can also change the tiers from hot to archive or from hot to cool. So in this way, we can reduce the storage cost of the storage cost we will incur for this storage. So this is a diagrammatical representation of the storage account, and this is a bash file. So I will put it in the description, the link in the description, and you can check this file. So this is about the first storage account, and we will see another configurations in storage account and security measures in second storage account in the second video. So stay tuned.